Hey, what's up, guys? Today we'll be doing sum of two values. So this is a very famous leak code problem. It's famously called two-sum, not sum of two values. But I think this is just like CSES just copy pasted this basically. But nevertheless, it's actually a really good problem, and I think yeah, I'll explain the problem first, and I'll explain why I really like it, even though it's so simple. So the idea is you have n integers and a target sum x. So in the test case or the sample test case, it's going to be 4. Or no, sorry, my mistake, 8. And it's going to be 4. And you're going to have n values, right? And you want to find two integers that sum up to x. So in this case, it would be 7 and 1. Okay. I think, yeah, there's several solutions you could print anyway. So anyone's fine. So the idea is just find a pair of integers, and they can't be the same one. So if I had a 4, I can't pick the same one twice and get 8. That's not possible. But yeah. So how should we go on implementing this problem? And I like to, especially with this problem, it's really easy to get to like a naive solution to like start off with a naive solution. So naive meaning like easy. So for a naive solution, what we can do is we can iterate through every single possible pair, right? And this will be I, and this will be j, and pointer I would be one index or one value, and then pointer j would be a separate value, and then you add the two and you brute force it. That's the idea. And this would be O of n squared. Every time you see like two for loops or something like that, you should probably think O of n squared. So there are like some I guess like exceptions to that, but every time you see two for loops, think of O of n squared. The issue with this problem is it's far too slow. It's 2 times 10 to the 5th, right? So I'll write that down. So this would be about this number right here, or 2 times 10 to the 5th. And usually when you use O of n squared solutions, they would usually be around the 1000 to maybe even 2500 range. There could be like upper and lower bounds to that. You can maybe get away with like 3000, I have no idea. But usually when you see like 3 digits, you're okay with O of n squared. Now in this case we have 5, or I mean 3 zeros. In this case we have 5 zeros. And usually with that, you want to get something around O of n log n. Now, if you're not familiar with time complexity, you should get used to it. But every time you should see like 10 to the 5th or any sort of factor of 10 to the 5th, or maybe even 10 to the 6th if you can get away with it, you're going to think of O log n, okay, n log n. So maybe like a sorting algorithm, I don't know, but n log n. So most commonly, it's probably going to be like sort. That's like the most common n log n thing. And yeah, that's what you're going to be kind of aiming for here. So the reason why I like this problem so much, even though it's so simple and it's not like complex or it has like something crazy, like a crazy algorithm to learn, is because like it really shows you the power of like basic data structures. So like maybe if you really dive into CP and other kind of, what do you call it? Competitive programming, ICPC, all that stuff in your future, like you're gonna get to like really complex data structures like RMQs, segment trees on trees. It can get really detailed and really crazy, but this really exemplifies the power of just something as simple as a set, hash map. I think there's a couple more that I'm like deck, priority queue, like these kind of like basic stuff, data structures you start at the beginning. And today we'll be using hash map. So yeah. So let's just break down what a hash map is. So in C++, so that's going to be what the video is tailored to. We're going to have map and unordered map. Okay. There is an underscore here. So I did put it, or I did find a Geeks for Geeks kind of website for it, or kind of article on it. So Geeks for Geeks has a lot of good stuff. You should check it out. But in C++, so this really actually does not matter. But the main idea is that maps have search time of log n, and then unordered maps have average of O1 and O(n) worst case. So you can use either one technically. Most people, like when you use unordered map, the benefit is that it's constant time search up time, but like on the worst case, it's like O(n). So like you could get really costly mistake, but it usually really doesn't matter. So most people like to use this map because it's just more consistent. But just remember that this is login query. Okay, ooh, wrong person. So just like I said earlier, we're aiming for that O of n log n solution. Okay, and map provides us with an O of log n query. So if you don't know what a query is, it's just like asking for a number. Okay, and this will be abundantly clear later on. So basically, in order to progress in this problem, you gotta know what your what hash maps do, or maps. So yeah, so how can we use maps? So with maps, you can store a group of data, and you can access it pretty quickly. In this case, we'll be storing a map of two integers, and one is going to be the value, and this is going to be the position. Okay, and so what we'll do, I think it's better just to look at the code. So don't think of like this esoteric macros and stuff like that. This is just input. So I'm just, in these two lines, I'm literally inputting x, or n and x, and then input the array. So this is the array. I'm going to make a map called m, and I'm going to loop through from, this is just from 0 to n-1. And I'm going to check in the map whether I have x minus ai, because there's only two values. You're only looking for two values. And so with that, that means if like we're going to look through, and if we already met like an element that contains the required like the other part that can add up to x, so like for example 1, right? If I've already met 7, which I have, it's good. That means we found an answer. Or for 2, for example, if I've already met 6, right? Because 8 minus 2 equals 6. So imagine two parts, right? Two sums, or not two sums, two elements, and then that's kind of like the idea. You have one element, and then you find a previous element before it. And then if I found it, I'm going to output it. So remember, the second value in m, I'm going to store what the index is, okay? And yeah, since there's only two elements, you don't have to worry about like duplicates and all like that stuff. Or like, since you're only looking for two elements, you don't have to look for duplicates and all stuff like that, but don't worry. Yes, and then we'll also output the current index plus 1 because it's one base indexed. Right here, one base. So yeah, that's kind of what we're looking for. And so so here's the key part. After, we're gonna put it into the map, and this works the reason for this is you don't want to use the same element twice. Okay, so if I'm accessing an element before it, or before I put it into the map, it just it checks all the previous elements, not the current element, if that makes sense. Yeah, so it's a little hard to understand, but I'll just like get a run for it. I think that'll be a very good idea. Yeah, I think that was it. So yeah, so I'll just keep. So this is gonna be my map. I'm gonna put it in red actually, so I like colors. So this is gonna be my map. So I'm gonna start with 2, right? So 8 minus 2, so 8 is x. So 8 minus 2 is 6, so I'm gonna check my map whether I have 6. Okay, I don't have 6, so that means it's a no-go. But I'm still gonna add it into my map. So I'm gonna add a pair of integers, 8 and 1. And this is gonna be my index, the second guy. Okay, let's move on. 7, okay. 8 minus 7 is 1, right? So that'd be 1, or actually, a minus 7 is 1. Do I see 1? No, I don't have a 1. So I'm going to put in 7, and then I'm going to put in 2. Keep in mind, if the element is greater than x, x minus whatever index is going to be negative. And that's good because it also detects, like, wait, do they have negative values in here? They don't, but whatever. It also detects, like, discrepancies like that. Okay, so 5, I'm going to check, okay, 8 minus 5 is 3. Do I have a 3? No, I don't have a 3, so I'm going to put it in, right? And here for 1, right? So 8 minus 1 is 7. I do have a 7. So I'm just going to say I'm going to output 2 because that's this guy right here. And I'm going to output I plus 1, which would be 4. And I got 2 and 4. Beauty. And the cool thing about this is, let's just say I had like another element 4. Or I'm going to replace this 1 with a 4. Right? And so the key thing is I check first before I add the element to the right. So if I check first, right, a minus 4 is 4. Do I see a 4? That's a no good, so that means it's not good. And then I'm going to put in the array. Yeah. But if I put in the element first and then did a check, so I just put it in right here, and I'm going to do a check, it's going to detect the exact same value, and that'll be an issue. Now, there's ways to work around it, but just like doing the query first and then inserting the element would be just easier. But yeah, so that's kind of the solution to the problem. I hope y'all enjoyed. And am I missing anything? Let me just check real quick. Okay, yeah, you just print out impossible at the end. So PS is just print. And with the comma, it just does spaces for me. And so if I found a value, I'll just return the function and just like end the, or end the, what do you call it? What? End the program. End the program. That's what I meant. So yeah, I'm gonna quickly submit it because I know you'll like to see the green. You can see all my past attempts. Those are from like a year ago. I wasn't that good at then, but you know, there's always room for improvement, and that's pretty fun. There is a sum of 3 values in this, not like in this data set. So yeah, AC accepted. So I hope you liked it. Remember, key things to remember: every time you see 10 to the 5th, you're gonna say, "Oh, login." Okay. Order login. So that'll be it for today. I hope you all have a great day.